Okay, so today I want to talk about how quadratics relate to real-world problems. If we're looking at a quadratic, just like this, okay, here is your y-intercept. Here is your vertex. Hopefully you can see that. So when you're talking about these things in real-world context, this right here will be how high off the ground did the object start. So this is the distance off the ground. Okay, so when we're talking about the vertex in a real world application, we've got time, can't see that, down here, and then this would be the height. Okay, so this would be your HK, your vertex. This would be when, so the time at which the object is at the max height, when max height. And this one is the y value, which is talking about how high. So that would be how high does the object get? Okay, so when you're talking about, we're going to be doing a problem starting on Monday when it's talking about a baseball. So I want you to start imagining a baseball leaving the ground and traveling, and then whenever you're seeing it hit right here, this is when you are going, I can't see that, when it's going to hit the ground at the 0. Okay, so at the positive 0, now there are 2 zeros in this quadratic function just like normal, but you have to think in real world application, is there a negative time? Okay, so technically when we're talking about real world stuff, there are negatives in real world, but when we're talking about a baseball leaving, we're talking about in accordance with time, there is no negative. So we're just simply talking about in this first quadrant, talking about the positive zeros. So this right here, this is 0, or the roots, or the solutions, or the x-intercepts, is when does the object hit the ground and how long does it stay. So this right here is going to be just like it's an xy coordinate. So this, your x value will be when, because it's talking about time. So when does it hit the ground? And then this one is talking about at or when and then how long. Okay. Okay. So I want you to start thinking about in the context of real world applications, because this is what we're going to be doing the next couple days. So think about how high is the object after how many seconds. Well, you have to be able to plug that x value in to the function to be able to see at what height is that going to be. Okay, and obviously you can have quadratics that are also you'll see falling, so it can be like this, or any kind of idea or quadratic that looks just like this. So I wanted to kind of wrap all of this up, and I'll probably give you a little guide on Monday of how it looks and kind of like a little cheat sheet for this, so that you can have that as well. Okay, I hope this helps, and I'll see you on Monday.